All right, so this weekend, what I have for you guys to watch is just a little bit of a review of everything we did last week. Because we did learn a couple new laws, but we also did review stuff that was from 2 classes ago. So on Monday in class, we're going to work on a review of everything we did this week, but it's all going to be mixed together. So you're going to have to be able to decipher when are you going to use law of sines, when are you going to use law of cosines, and when are you just using right triangle trig. So one of the first things that we looked at on Tuesday was just going back when you have a right triangle, what sine of A, cosine of A, and tangent of A. So again, sine is your side opposite of the angle over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is opposite over adjacent. So again, when you draw your triangle, how do you know opposite, adjacent, and tangent? It's all relative to where your angle is. So if my angle A is over here, and I have my right angle here, your hypotenuse is always across from your 90-degree angle. Opposite, if we were to go across from A, so side A, that would be your opposite side. Adjacent would be the side that's right next to your angle. So that's how we can tell opposite, adjacent, and hypotenuse. And we had also gone over and reviewed a couple of theorems or postulates that were helpful when we know we have a right triangle. First one's the Pythagorean theorem. Once we know two sides, we don't need to use right triangle trig. We can just use Pythagorean theorem once we know two sides in order to find the third. And then we also knew that all the angles have to add up to 180 degrees. So again, once we know two angles, we don't have to use any of our laws or trig. We can just add up 2 and subtract that number from 180. And then again, in case you don't remember, a lot of people use the SOHCAHTOA to help you remember their sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so then what we did after we went over these is we looked at how to solve a triangle, meaning find all the missing pieces based on the information we have. And so from there we looked at angles of elevation, angles of depression, as well as bearings. So bearings are when we measure things from a vertical north-south line, and we can either go from the north side east, from the north side west a certain degree, from the south side east, or the south side west. And it's all dependent upon what the problem tells us. But we also have, if you want to draw your east-west axis, it helps us determine a quadrant or a direction from a north-south line. We also had elevation and depression. Those were similar in the sense that they were measured from a horizontal line. We don't call it east-west, north-south when we talk about elevation and depression, but it's from a horizontal position. Are you measuring going up from a horizontal position, because that's elevation? Or are we going from a horizontal position downward, giving us an angle of depression? So those were where we did a lot of word problems in dealing with those terms and how those terms help us draw a picture that we can then use either right triangle trig or even law of sines or cosines on based on the information in our picture. Okay, after we had done some word problems with right triangles in these terms, we learned about our law of sines. And our law of sines set up a bunch of ratios for us that we knew to be equivalent. So sine of angle A over side A, which remember is the opposite or across from A, is proportional to sine of B over its opposite side B, which is also proportional to sine C over its opposite side C. And so we only ever use two fractions, two of these ratios to set up our proportion, but they do help us with law of sines and finding the missing pieces of our triangle. Now, one thing we haven't learned yet is there's something called the ambiguous case. So we've kept our problems for you so far for law of sines pretty simple, one answer. But there actually is the possibility for two answers when you use law of sines sometimes. And so what we're actually going to do on Tuesday is we're going to go over law of sines again, specifically when you have this ambiguous case. So for right now, things are still good. We don't have that in our mix yet, but that's kind of where we're going after today. We had also learned our law of sines, or sorry, law of cosines. And this one had three parts to it, depending on which angle we were using. So using angle A, it had to be across on the opposite side of the equation as side A. When we used angle B, we have to put B on the opposite side of the equation. And when we want angle C, we have to move C to the opposite side of the equation. And so our law of cosines and our law of sines were again used for non-right triangles. So both of these are for non-right triangles. Could we use right triangles in these laws? Yeah, it's just gonna, if we plug in 90 for A and a cosine, what's cosine of 90? 0. So what happens to this? Goes away and you just have the Pythagorean theorem. So yes, you could do a 90-degree triangle if you didn't realize you had one. It'll just, things will cancel out and it'll become a much simpler fraction or a much simpler problem. But we tend to only use them for non-right triangles, because when we have a right triangle, we have the more simplified ratios to use. So this is pretty much what we did last week. We learned our law of sines and cosines. The only thing we haven't done yet is the ambiguous case for law of sines. We're headed to that next. And then we went over our basic right triangle trig, and then we also learned about bearings. So for right now, you have to make sure you know these laws, these ones here. I don't believe you get to use a note card or anything on this one because we're doing everything in a calculator, so we don't even need our unit circles. So for right now, and I'll talk with Ms. Torres, I don't believe we had you guys use anything in the past, so I don't believe you'll be able to use anything here. We only have about a week left, so we're going to learn the ambiguous case, and then we have a little more word problem practice where we might have to use law of sines and cosines. So if there's any questions or clarifications that you need on any one of these topics, come with any of clarifying questions on Monday, and we'll go over them before we do a little bit of a review worksheet on all of this mixed together.